Hi, Mrs. Spohn here, and this is our second installment of our mole series, and we're going to look at the how to calculate the molar mass or formula mass of molecules like H2O or ionic compounds like NaCl, or even more complicated things like sugar and so on. So we're going to try to figure out the molar mass of compounds, and the first thing we're going to do is start with water. What is the molar mass of H2O? And before we talk about moles, I'm going to stick with the word dozen again to make sure we understand what's going on. So this is one water molecule right there, H2O, two hydrogens bonded to an oxygen. And for now, I'm going to ask you, what is the mass of 1 dozen water molecules? So if we had a dozen water molecules, like you see pictured up here, what is the mass of a dozen water molecules? And I'm going to define some things that are not at all true. Let's say that a dozen oxygen atoms, 12 oxygen atoms, would weigh 16 grams. Not at all true, but for simplicity, we're going to use that. And let's say a dozen hydrogen weighed 1 gram. Well, if we had a dozen water molecules, would we not have a dozen hydrogen atoms? Because every water molecule has one, and there's 12 of them. So we're going to have a dozen of oxygen. And would we not also have a dozen of these and a dozen of these, making 2 dozens of hydrogen? Because each water molecule has to have one hydrogen in it on the left, making for 12. And each molecule has to have one hydrogen on the right, making for another 12. And we're saying that oxygen weighs 16 grams per dozen. And we had 1 dozen of oxygen, right? And we had a dozen of hydrogen, which weighs 1 gram per dozen, right? There's going to be 12 of these up here. But there's also going to be another dozen of hydrogen because we have 2 hydrogens in water. Essentially, you end up with 2 dozens of hydrogen. And really, to figure out the weight, what would all this water weigh? Well, the dozen of oxygen weighs 16 grams. The dozen of hydrogen on the left weighs 1 grams. And the dozen of hydrogen on the right also weighs 1 gram. So what do? We just add them together. And that means hydrogen would weigh 18 grams per dozen. And again, this is not at all true, but there is one thing we can do to make this true. You can replace the word dozen in this. Everywhere you see the word dozen, you can put in the word mole. You can put in the word mole. Everywhere you see dozen. A mole of oxygen is 16 grams. A mole of hydrogen is 1 gram. If we had a mole of water molecules, we would have a mole of oxygen. We would have a mole of this hydrogen. We would have another mole of this hydrogen. And of course, this unit down here would be mole, mole, mole. And we would end up with 18 grams per mole. Exactly what we're going to do. So I know the word dozen is easy to understand, but it's the same exact thing when we're talking about moles. So let's go here. What is the molar mass of H2O? Well, I'm asking for the mass of 1 mole of water, and that means you're going to have 6.022 times 10 to the 23rd units of water. This is 1 molecule of water here on the left, but I want to know a mole. I want to know what 6.022 times 10 to the 23rd of them would weigh if put on a scale. And we would have a mole of oxygen, a mole of hydrogen, and another mole of hydrogen. And of course, when you add them all up, the molar mass of water is 18 grams per mole. So all we really did to simplify this was we kind of looked up these elements on the periodic table. There's 2 hydrogens and 1 oxygen. Hydrogen is 1 gram per mole, 1 gram per mole, and oxygen was 16. Remember, this isn't diatomic because oxygen is not by itself as a gas. It's connected to the water, so we use the 16. So 16 plus 1 equals 18. And that's really all you got to do to figure out the formula mass of molecules or ionic compounds. So let's look at CO2. What is the molar mass of CO2? Our first step is to count atoms. How many carbon atoms? How many oxygen atoms? We got to make sure we can read chemical formulas. This one's pretty simple, but they do get more complex. There's 1 atom of carbon, which has a molar mass of 12 grams per mole, and there's 2 atoms of oxygen. Oxygen is 16 grams per mole for a single oxygen. So now we're going to add the molar masses of the constituent atoms. And what did we do here? We realized that carbon, the 1 carbon, is 12 grams per mole, plus, well, the oxygen, which is 16 grams per mole, but we have 2. We could have did 16 plus 16, but instead we multiplied it by 2. So 12 grams per mole plus 2 times 16 grams per mole, and that's going to be 44 grams per mole. So each oxygen is 16 grams per mole, and the carbon is 12 grams. And you just add those three numbers together. That's all you got to do. So let's say we had magnesium nitrate, and again, this one's a little more challenging for counting atoms, but we can do it. First thing is to count atoms. Magnesium, how many do I got? 1. This 2 over here only applies to the parentheses. That's directly before it. How many nitrogens? 2, because this 2 applies to the whole parentheses. It's like saying we have 2 of these. And how many oxygen? Well, this 2 applies to the parentheses. You have an O3 in here, but we have 2 O3s, so we have 6 oxygen. And these are our periodic table boxes for magnesium, nitrogen, and oxygen. And after we count our atoms, we add the molar masses. So there's 1 magnesium, 2 nitrogen, and 6 oxygen. Magnesium is 24.3 grams per mole, nitrogen is 14.01, and oxygen is 16 grams per mole. Where does the 6 come from? Well, there's 6 oxygen atoms. And we're just going to add all these numbers together. So the magnesium in here is 24.3 grams plus the 2 nitrogen, 14.01 per mole, but we have 2 nitrogen, so we multiply that by 2 plus 6 times 16 for oxygen, because there's 6 oxygen atoms. So we count atoms and then just look at the periodic table and add them up to determine the molar mass. And we'll do one more example, sucrose. So we got to count atoms and then add the molar masses together. This one, counting atoms, is pretty easy here. There's 12 carbon, 22 hydrogen, and 11 oxygen. And of course we have our periodic table boxes. We know the bottom number is the molar mass. So carbon, there's 12 carbon, 22, and 11 oxygen. And carbon is 12 grams per mole, right? 12 grams per mole, but there's 12 carbon. So 12 times 12 plus whatever we end up in here. Hydrogen is 1 gram per mole, but there's 22 of them. So 22 times 1. And oxygen is 16 grams per mole, but we have 11 of them. So we have 11 times 16. And of course we add these three numbers together, and that gives us the molar mass, or the formula mass, of sugar. And we end up with 342.3 grams per mole. It's not too complicated. That's all you got to do. Hopefully you can now determine the formula or molar mass of ionic compounds and molecules. This is Mr. Zapone. I'm out.